Physics, Chapter 10, Heat. We are going to be doing a section on Chapter 10.3, Changes in Temperature and Phase. You will have a chapter test on either the 15th or 16th, and the 17th you have no school. Today's lesson outline, a very quick quiz on thermometer activity and changes in temperature and phase. You're going to get a handout, and then in class you're going to do practice problems 10C and 10D. Your only homework assignment for today is to review for the Chapter 10 test. If you have any questions, make sure you see me before the test to get them answered. The learning targets for today's lesson is I can calculate specific heat capacity and latent heat, and I can interpret various sections of a heating or cooling curve. Changes in temperature. The heat required to raise a unit mass of a substance by 1 unit temperature interval under specific conditions such as constant pressure is usually measured in joules per Kelvin per kilogram. It is considered C of P and is called specific heat capacity. We're going to use Celsius and grams. Your textbook uses kilograms, and I am still using grams. Either one is fine as long as you convert to either grams or kilograms. The specific heat capacity is also known as a specific heat. It is the energy required to raise 1 gram of a chemical by 1 degree Celsius. It has a unit of joules per degree Celsius grams. Some substances need a lot of energy to raise their temperatures, others less. Here are some examples. We will be focusing mainly on water and some metals, and I will give you their specific heat capacity. What amount of heat energy, which is Q, is required to raise 20 grams of water by 30 degrees Celsius? Your mass is 20 grams. Change in temperature is 30 Celsius. C of P of water is 4.18 joules per degree Celsius gram. Your unknown is Q. When you plug the numbers in, you end up with either 2,508 joules or 2.508 kilojoules. You can either leave the answer in joules or convert it to kilojoules. I'm not concerned about that as long as you convert. The amount of heat energy needed is required to boil 30 milliliters of water from a temperature of 25 degrees Celsius. The givens are mass is 30 milliliters. In water, 1 milliliter is equivalent to 1 gram, so it's 30 grams. Change in temperature is 100 degrees Celsius minus 25 degrees Celsius, which is equal to 75 degrees Celsius. Specific heat is 4.18 joules per degree Celsius grams. Again, the unknown is Q. When you do the work, you end up with 9,405 joules or 9.405 kilojoules. This is an example of a sample problem that is in your textbook. I will leave this up for a moment, and you can go through and see how all of this was done. Changes in phase. A change from one state, solid, liquid, or gas, to another without a change in chemical composition. The most common phases, and the ones we see on the Earth, are solids, liquids, and gases. Less common or uncommon are the Bose-Einstein condensate and plasma. Bose-Einstein condensate is at a lower temperature than a solid, and plasma is at a higher temperature than gas. You can also see the various transformations. For example, a solid going to a liquid is melting, a liquid going to a solid is freezing. What happens during an phase change is that heat is either absorbed or released. Heat energy is released as molecules slow down and move closer together. Heat energy is absorbed as molecules speed up and expand. Melting. This is a phase change from a solid to a liquid. Molecules speed up, move further apart, and absorb heat energy. Freezing, on the other hand, is a liquid going to a solid. Molecules slow down, move closer together, and release heat energy. Vaporization or boiling is a phase change when a liquid goes to a gas. It occurs at the boiling point of matter. Molecules speed up, move further apart, and absorb heat energy. Evaporation is the opposite. It is a liquid going to a gas. On the surface of a liquid, it occurs at all temperatures. Molecules speed up, move further apart, and absorb energy. Condensation is a gas going to a liquid. Molecules slow down, move closer together, and release heat energy. Sublimation is a phase change directly from a solid to a gas. They skip the liquid phase altogether. Molecules speed up, move further apart, and absorb heat energy. A very good example of this is dry ice, which is a solid carbon dioxide going directly to a liquid or gas carbon dioxide. Deposition is a phase change directly from a gas to a solid. Again, they skip the liquid phase. Molecules slow down, move closer together, and release heat energy. Frost is an example of deposition. Why does temperature remain constant during a phase change? If you graph the heat added to a system versus the system's temperature, the graph usually slopes upward. Adding heat increases temperature. However, the graph levels out during the phase change because on a molecular level, making a substance change state requires energy. After all of the matter has changed state, the temperature can rise again. So all of the energy is going into the phase change. None of it is increasing the temperature of the substance. Summary: water's phase changes. You have a solid water that melts into liquid water that evaporates into water vapor, which in turn goes in the opposite direction. Water vapor condenses into liquid water and freezes into solid water. Heat energy is released, going from water vapor to a solid water. Heat energy absorbed, going from a solid water to water vapor. A couple of things you should think about. Why is there no change in temperature during a phase change? Be able to define melting and boiling points. What is the melting point and boiling point of water? And at what temperature does water freeze and become a solid? This is an example of a heating and cooling graph. You'll notice that the cooling graph is a mirror image of the heating graph. This is true for most substances. Heat of fusion on page 378 is the difference between energy needed to break bonds in a solid and the energy released when bonds form in a liquid. You can take a look at this on page 378. Heat of vaporization is on the next page on page 379. It is mostly the energy required to separate molecules from the liquid phase. You also have a latent heat of fusion and vaporization table in your textbook. It is on the same page as one of the graphs before. And then you have sample problem 10D. How much energy is removed when 10 grams of water is cooled from steam at 133 degrees Celsius to a liquid at 53 degrees Celsius? You can use tables 10-4 and 10-6 to solve this problem. Again, I'm using grams. Your only homework is to review for the Chapter 10 test.